So let us talk about biodegradable polymers. See, most of the synthetic polymers that we use in our day-to-day life, they cannot be degraded, easily. So they would create environmental problems, right? They create a lot of environmental pollutions because the degradation of these polymers would either take a very, very, very long time, or the degradation might not be easily possible in the environment, right? And therefore nowadays people have been thinking about finding such polymers or making such polymers which have functional groups that are very similar to the functional groups which we find in biopolymers. Biopolymers are degradable polymers. These are naturally occurring polymers. They can be easily degraded in environment, and therefore even new polymers which we now try to synthesize, they generally have a similar kind of functional groups in them, and hence they have been designed so that even these polymers which are synthetically made, they can be degraded in environment easily and would not cause any pollution. We have about two or three in this category that we need to discuss. Let us take up the first one. So let us take up the first one. This one here is called PHPV in short. It is basically a copolymer of beta hydroxybutyrate and beta hydroxyvalerate. Now, valerate basically is given for a compound having 5 carbons. So let us understand how this goes. There are two different monomers used, and this is like a butanoic acid which has 3 hydroxy in it. So it goes like this. It goes like this: CH3, CHOH, CH2, and COOH. You take N molecules. This is like the, alpha, and this is the beta position. So beta hydroxy. So I can give a name here: 3 hydroxy or beta hydroxy. 3 hydroxy butanoic acid. And you also have N times 3-hydroxypentanoic acid. So that goes like this. This is your 3-hydroxy or beta hydroxy. And this would undergo polymerization, and upon undergoing polymerization we have a polymer formed like this, wherein you have O, then CH and CH3. Basically the reaction occurs here and here. So CH3 is a branch then, and then we have this CH2, then we have C double bond O, and then CH, and then CH2, CH3. Ideally this also goes as a branch because connection occurs here, and then we have C double bond O. This is N times, and therefore we have it here. This is alpha and this is beta, right? So that is what we have. Here, this is also called PHPV. This is called PHPV, right? All right. So this is the polymer that we have here. This is a kind of biodegradable polymer. Here you have to know that this imparts stiffness. So if you have greater amount of 3-hydroxybutanoic acid taken, there is more stiffness which is given, and this imparts flexibility. So ideally, if you want more flexibility, you have to add a greater quantity of pentanoic acid, and if you need more stiffness, you will have to add a little bit more of hydroxybutanoic acid. So a balance of two would generally decide everything, right? And now let me give you the uses, but before that, let me put this all together properly. Yeah. Now we move on to the uses. First, very good packaging material. Two, it is also used for making capsules for controlled drug release. And third, a lot of orthopedic devices are prepared from it. So making a lot of orthopedic devices. These are some of the important uses. These are some of the important uses of PHPV that we have here. Okay. Now we go to the next polymer, which is called nylon 2 nylon 6. So let us move on to nylon 2 nylon 6. That's one more. Now here, this is also a copolymer, a biodegradable polymer once again. One of the monomers is glycine, the other one is aminocaproic acid. And here you have the same thing. There's loss of water, condensation, polymerization occurs, and you have nylon 2 nylon 6. This is again a very important biodegradable polymer that we have. The next that we have, the third category that we have here is something called PGA, polyglycolic acid, polylactic acid, PLA. This is also called dextron. And this is again a very important polymer because this is used for making sutures, which are self-dissolving sutures, which are used in post-operative stitches, right? So that's a very important part. And here you can have your glycolic acid, which is like OH, CH2, and then COOH, N molecules. And you can have your lactic acid, which is like CHOH and then CH3 and COOH. Then there is this polymerization. And this polymerization would result into the polymer. Here you have O, CH2, because OH would always lose H, and this COOH would lose, OH, and then you have this polymer. This is basically your polyglycolic acid, polylactic acid, PGA, PLA, right? And as I've told you, what is the use? The use is used in making self-dissolving sutures for post-operative stitches, right? A very important part here. All done now. Now we have a few extra things that you have to know. So let me talk about one or two extra polymers that you have to know. The first one here is like your urea and formaldehyde resin. We've already done phenol and formaldehyde, melamine and formaldehyde resin, all of that. This is urea and formaldehyde resin. This is also used for making unbreakable cups and all. The polymer goes like this. This is the NH of urea, then C double bond O of urea, then you have NH, and then you have CH2. So basically this gets repeated n times. Unbreakable cups and laminated sheets and all, they are made from this urea formaldehyde resin. So you have to know this, right? So used for making cups, laminate sheets, etc. Uses. And the second one here is called Glyptal. Glyptal is a polymer which is made from ethylene glycol, and it is phthalic acid and ethylene glycol, right? They combine. So I can have, first of all, I'm drawing the ethylene glycol part, and then now I can put it up like this in the same way. This would be like your phenyl ring. This is your Glyptal, right? How is it formed? Obtained from ethylene glycol and phthalic acid. Used in manufacture of paints and lacquers. All right, so this is it. We've finished off most of it now, and the chapter is done. This was the last video, right? So go through this, revise this, and if you have any doubts, you can even ask me in my regular class. Thank you so much.